Good day, viewers. This is Empirical Johnson, your science tutor. Today, I also want to look at something in chemistry, that's empirical formula and molecular formula. We are starting first with empirical formula. Empirical formula. Empirical formula. When we're talking about empirical formula is the simplest formula. The simplest formula of a compound which contains the relative number of all kinds of atoms in a molecule of a substance. So what you have there is empirical formula. So empirical formula is the simplest formula of a compound that contains a relative number of all kinds of atoms. Relative number means the number that is related. It's not the actual number. It does not contain the actual number. So it is often obtained. By quantitative analysis. Obtained by quantitative analysis. Now, what is molecular formula? Molecular formula is the actual formula or the real formula of a compound or of a substance. Mind you, this one also I need to change it of a substance, because a substance can be an element or a compound, so it's not restricted to only compound. So the formula of a substance which shows the actual number, this time around not relative number, the actual number of all kinds of atoms in a molecule of a substance. Now, molecular formula can be determined. You can get it from two things. The molecular formula of a compound or of a substance can be calculated by equating its empirical formula. to its relative molecular mass or double of its relative vapor density. What do I mean? You can equate the empirical formula to the molecular formula. The empirical formula to the relative molecular mass or 2 times relative vapor density. And so you can do that. Let's look at some comparison here. Look at this table, serial number. Let's look at substance, name, substance name, then the molecular formula, the value of n, then we come up with empirical formula. Now, number 1 here, I have benzene. The molecular formula of benzene is C6H6. Then, in that formula we are given, you will see that 6 is common to both carbon and hydrogen. So, from our knowledge of factorization in mathematics, this end is this. If we factorize this is out, the empirical formula becomes CH6. So that is the empirical formula. Or CHN. So where your N now is what? Is 6. So let me just put N, CHN. And your N is what? Is 6. Now number 2, ethyne. Ethyne is C2H2. What is common to both carbon and hydrogen is 2. If you factorize it out, it also gives you what? CHN. So it is possible for 2 compounds to have the same empirical formula, but it is not possible for 2 compounds to have the same molecular formula. So that is what you are seeing there. Now, because the empirical formula is not the actual formula, so then we have water. The molecular formula of water is H2O. You will see that the only number that can be factorized out is 1. And the molecular formula is what? H2. So this is a case where it is also possible that there are some compounds that their empirical formula is the same thing as their molecular formula. Example is water. Now look at this. Let me give you more examples. We have hydrogen peroxide. Hydrogen peroxide. The molecular formula is H2O2. So what is common to hydrogen and oxygen is 2. Factorize it out, we have what? We have HON. So that is that. Now we can have some more other ones like ammonia. Ammonia is NH3. What's common? 1. So we have NH3N is a empirical formula. We can go on and on and on and on. So, like that. What about ethanoic acid? Ethanoic acid CH3 COOH. This is structural formula or condensed formula. But the molecular form or this is the condensed formula, can write as this. This is the structural formula. Now, but we are not dealing with that here now to get organic chemistry. So here, you can visit my videos in YouTube under organic chemistry. I've done a lot of videos on that. So the molecular formula now is going to be 1, 2 carbon. That's C2, H what? H1, 2, 3, 4, H4, O what? O2. This is the molecular formula. What's common? 2 is common here. So factorize 2 out to have C, H, 2, O, N. So if you use 2 to open this bracket, if this N is your 2, you have C2, H2 tends to 4, O2. So that is that. So we have more examples as we have uncountable compounds. So we cannot exhaust the examples we have. Now, let's quickly now look at calculations involving the empirical formula and molecular formula. So let's look at example 1. Example 1. They say a compound was found by analysis to contain that's 46 gram of sodium, then 12 gram of carbon, and and 48 gram of oxygen. Then you now say find the empirical formula of the compound. Find it, then they will give you Na is 23, C is 12, O is 16. Now, if you want to solve a problem like this, what do? You are going to create a table. Write the symbol of all the elements mentioned here. The first one is it contains 46 grams of sodium. Sodium is Na. 12 grams of carbon. Carbon is C. And what? Oxygen. Then you have to memorize these 4 steps. First one is percentage composition by mass. You have to cram this. Then the next one is relative atomic mass. Relative atomic mass. Then apart from that, we have mole ratio. Mole ratio. Then apart from that, we have divide through by the smallest smallest mole ratio. Divide all through by the smallest mole ratio. Then from here, you begin to supply, want to fill in this table. We have a compound 46 grams of sodium. You put 46 here. Then 12 grams of carbon. You put 12 here. Then we have 48 grams of oxygen. You put it here. That's there. So percentage composition can be in gram or in percentage. Now relative atomic mass is what we are giving here. Sodium is 23, carbon is 12, oxygen is what? 16. So mole ratio in mathematics means to divide. Divide this upper number by this lower number. 46 over 23. And this one is what? 12 over 12, of course. Your answer is 1. And here is 48 over 16. So your answer here should be 3. And the answer here should be 2. So what is the smallest number here? 1. So divide these 2 by 1. 2 over 1. Answer is what? 2. Then divide this 1 by 1. Answer is still 1. Divide this 3 by 1. Answer is 3. Haven't gotten that. Haven't gotten that. You can now say, okay, the empirical formula will now be, write this NA, this symbol, NaCO, NaCO, NaC and oxygen. So under Na, what did you get? 2. You put the 2 here. Under carbon, what did you get? 1. No need to put anything here. Then under oxygen, what did you get? You get 3. So the compound is Na2CO3. That is the empirical formula, which is also the molecular formula. Let's look at example 2. Example 2. They say a hydrocarbon was found by analysis to contain 7.7% hydrogen. Then they now say find the empirical formula of the hydrocarbon. And they give you something like this: H equals to 1, C equals to 12. That is a question. That's another question there to talk about. Now, what do we do to tackle this problem? Now, to tackle this problem, we are writing our table. In our table, we have carbon and hydrogen. Because they say the compound is hydrocarbon. Say the compound is hydrocarbon. So if the compound is hydrocarbon, it contains carbon and hydrogen. So you go on with percentage composition by mass, percentage composition by mass. Then the next to look at is relative atomic mass, relative atomic mass. Then we have mole ratio, mole ratio. After that we have what? Divide through. by the smallest mole ratio. So here we have this. What do we do? Under carbon, when we are not given anything under carbon, we only give one number. It contains 7.7% hydrogen. 7.7. And don't forget, this compound only contains carbon and hydrogen. So addition of the percentage of carbon and hydrogen should give you 100%. So if 7.7% was given to you to be percentage of hydrogen, the number that will be added to 7.7% that will make it 100% to be the percentage of carbon, which is not given to you. So here will now be 100 minus 7.7. So that gives you what? We have 100 minus 7.7. So answer is 92.3. So our relative atomic mass for carbon is 12, hydrogen is 1. Mole ratio will now be what? Where did I see the 12 and 1? 12, carbon, hydrogen is 1. So we have here 92.3 over 12. This one over this. Then this one 7.7 over 1. So let's check. Over 12 should give me 7.7. So and this one is also what? 7.7. So if that is the case, my empirical formula now, I can go ahead now and say empirical formula will now be, what is this? Carbon. Carbon is what? Oh, what am I doing here? Divide through by the smallest. I'm not true. The smallest is this 7.7 over 7.7. That's 1. Then 7.7 over the same 7.7. That's also 1. That's CH. So my empirical formula is CH. So C1, H1. So no need of putting the 1. So I am through with that question. So let's look at another question here. So now let's look at example 3. Example 3. A compound was found on analysis to contain 56.0 gram iron, 71.0 gram chlorine, and 36.0 gram water of crystallization. Find the empirical formula of the compound. So this is another work here on the board. So to do this, they will also give you Fe is 56.0, Cl is 35.5, then H is 1, O is 16. So you are doing something like this. What do we do to solve this problem? So we are going to draw our table as usual. Now, Now, where we have what? Iron Fe, Cl, water crystallization is H2O. So we have percentage composition by mass. We have relative molecular mass, relative atomic mass. Then we have mole ratio. Then we have divide through by the smallest. So now, according to the question, let's begin to fill this table with what we are given in the question. So we asked the compound was found by analysis to contain 56.0 gram iron, 56.0, then chlorine 71.0, and water crystallization is 36.0. The relative atomic mass of iron is still the same as 56.0. That of chlorine is 35.5. Water crystallization, of course, to find molar mass of water, that's 1 times 2 plus what? Plus 16. So answer is what? 18. That's 2 plus 16, which is equal to what? 18. 1 times 2, 2. Then plus this, that's 18. Then the mole ratio will now be 56.0 over 56.0. Answer is 1. Then here is 71.0 over 35.5. Answer is 2. Then here is what? 36 over 0 over 18. That's what? Also 2. What is the smallest number here? 1. Divided by the smallest. 1 over 1 is 1. Now 2 over 1 is 2. Now 2 over 1 is also 2. Now, what do we have now? The empirical formula now. The empirical formula is what? It's going to be Fe, which is this. What number? 1, don't need to put in it. Cl is what? Is 2. Then H2O, these 2, because it's water crystallization, you must put dots and put these 2 behind H2O. So the name of this compound is iron 2 chloride. Iron 2 chloride dihydrate. Iron 2 chloride dihydrate. We are going to learn that in third term SS1, where we'll be talking about acid, bases, and salts. So that's hydrated salts. Now let's go on. Now, okay. Now, if you say example 4 now, they say a compound contains divide 7.7 over 1 contains 7.7 mole hydrogen and and 7.7 mole carbon. Find the empirical formula of the compound. not give you relative atomic mass of carbon and hydrogen, since they are giving you their number of moles. So what do? If you do your table, you have carbon, you have hydrogen, and you have percentage composition by mass. You have relative atomic mass. Now, then the next one is mole ratio. Then divide through by the smallest mole ratio. So here, the first two steps are bypassed. They have already helped you to find the percentage composition, that find the relative atomic mass. Now they only give you what the numbers given here now in mole. So you start here, 7.7 and 7.7. That's mole ratio. So divide through by the smallest. The smallest is what? 7.7 over 7.7. Answer is 1. 7.7 over 7.7. Answer is also 1. So they have helped you already. So you are not going to talk about the first table. Okay? So now you just go and say empirical formula. You have the word C1H1N. Simple. Now, example 5. Let's do the one that concerns molecular formula now. We have done enough examples of empirical formula, molecular formula. They say a compound was found by quantitative analysis to contain 72 gram carbon and 6 gram hydrogen. Now, if the relative atomic mass of the compound is 78, find the empirical formula, molecular formula. So here you are given C equals to 12, H equals to 1. So that's what you are given. So if that is it, you want to solve this problem, now what do we do to solve this problem? We do our table. So we say carbon and hydrogen. You put carbon here, you put hydrogen here. So we have percentage composition by mass. We have relative atomic mass. Then we have mole ratio. And we have divide finding this, according to the question, carbon is what? 72 grams. Hydrogen was what? 6 grams. The relative atomic mass of carbon according to here is 12. And that of hydrogen is what? Is 1. So the mole ratio will now be 72 over 12. That will give us 72 over 12. Answer is 6. Then here we have 6 over 1. That's 6. The smallest is 6. So 6 over 6. 6 over 6. 1, 1. Roman figure 1 now. Empirical formula. You give us CHN. C1, H1. So that's CHN. Then to go on, so the next one, number 2. Now we have to equate this empirical formula N. So you cannot find molecular formula if relative atomic mass is not given. So equal to 28. Then find the molar mass of what is here. Carbon is already 12. Hydrogen is 1. So under carbon I put 12. Hydrogen is what? 1. Then I put this N. I equal to 78. Do this operator 13N equals to 78. This is 12 plus 1. So we have, divide both by 13, we have 78 over 13. So our N equals to what? 78 over 13. Answer is 6. So number 2 now, molecular formula. Molecular formula now will be what? CH what? N. Where N is 6. So we have CH6. So if that is it, open up the bracket, we have C6, DC, then H what? H6. So that's the molecular formula. So let's look at another example. Example 6 now. Example 6. They will say, now if the empirical formula of a compound whose relative molecular mass is 180 is found by analysis to be CH2O. Find the molecular formula. Of the compound. Then they give you C equals to 12, H equals to 1, O equals to 16. Yes, that's a question for us. This one now you don't need to draw any table. They have already drawn the table and found the empirical formula for you. Your own is to go on and look for the value of N and go your way. For the value of N and go your way. Now, to solve this solution, the empirical formula has already been given to you to be CH2O, then N, and the relative atomic mass has been given to you to be 180. So we write it 180. So already carbon is what? 12, plus hydrogen is 1 times 2, then plus oxygen is what? have 12 plus 2. 1 times 2 is 2 plus 16. N equals to 180. So let's add everything there together. We have 12 plus 2 plus 16. Answer is 30. We have 30N equal to 180. So we divide those out by 30. We have 30N over 30 equals to 180 over 30. This 30 cancel out this. N equals to what? That's 6. So that's 6. So now, coming back, the molecular formula will now give us CH2O N, where N is what? Where N is 6. So if N is 6, then the molecular formula will be CH2O 6, which is the same thing as C6. This goes under this. H 2 times 6, 12. O what? 6. Finish. So we are done with that. Now, what about the case where you are given vapor density? Where you are given vapor density? You see, example 7. A compound was found by analysis to contain 12 grams of carbon. Okay. 12 times 6. Okay, sorry. 72 grams of carbon. Then hydrogen is 2 grams of hydrogen, 12 grams, and 96 grams of oxygen. If the relative vapor density of the compound is 90, find the empirical formula. Two, the molecular formula. So they will give you C equals to 12, H equals to 1, and O equals to 16. So that's the last question we're going to solve today. I think we have done well under empirical formula, molecular formula, as far as SS1 syllabus is concerned. So let's come to this place. So first thing is to draw our table. Then we have carbon, hydrogen, and oxygen. So we have percentage composition by mass. We have relative atomic mass. We have mole ratio. And we have divide 2 by the smallest mole ratio. So, for sake of by mass of carbon according to the question is 12 grams. And that of hydrogen, this one is 72 grams. This is 12 grams. And that of this one is 90 what? 96 grams. So then the relative atomic mass of carbon is 12, that of hydrogen is 1, that of oxygen is 16. So the mole ratio will now be 72/12. 72/12. That is 6. And this is 12/1. That is 12. And this is 96/16. 96/16. That is also 6. So the smallest number here is 6. 6/6 is 1. 12/6 is 2. Then 6/6 is also 1. So we have to go 1 now. Empirical formula. Will now be C1H2O. And we put our N. This is what these people did. In the previous question we did the other time to have gotten the empirical formula to be CH2O. They did it for that time. So we are doing it now for ourselves. Now, number 2. So we have to go through now. They say to find molecular formula. We start with our empirical formula CH2O. But here now they gave us, they say if the relative vapor density they give us not relative atomic mass. If they give us vapor density, we multiply the vapor density by 2 before we use it. Because vapor density is half of relative atomic mass. So take note of that. The half of relative molecular mass is a vapor density. So take note of that. So now, what are we going to do? Carbon is 12, hydrogen is what? 1 times 2, oxygen is what? 16, all N equal to 180. This one and this one. So what we have here, add up, we have 12 plus 2 plus 16, everything N equals to 180. So this is add everything, you have 30N equals to 180. Divide both sides, you have 30N/30 equals to 180/30. 30 cancel 30, N equals to what? 6. Now, then we have to go to now the molecular formula. Okay, we can now say CH2O, N, where N equals to 6. We have CH2O 6. So then we now have what? The molecular formula. Will now give us what? Will now give us, open up the bracket, we have C6. H2 times 6, 12, O6. That is that. So that is the end of this topic. So if there's any question you need to ask that you don't understand, visit the comment section and put your answer there. Or reach me with this number 070 30 39 35 31. I feel anyone will respond to you. That's my WhatsApp number and that's my call number. So I'll see you next time in the next video where we'll be talking about chemical equation. God bless you and bye for now. Thank you. Please try to subscribe. Click the subscription button, subscribe and share this video. God bless you.